This snapshot video is in regards to repetition in counting. What do we mean by repetition when we count how many ways we can do something? This is going to be the third step in the process. Recall the first step involves identifying the task and listing what you need to do. Step 2 was identifying the group or groups involved and how many. In the third step, we do the actual counting process. But there is one thing we also need to consider when we actually start counting, and that is the concept of repetition. In the third step of counting process, you will need to decide if something may be selected more than one time. This is referred to as repetition. So, can something be selected more than once? Sometimes it can, and sometimes it can't. It depends on the particular thing you're doing in the context of the problem. So, we start counting, but as you do, ask yourself, can something be selected again? Remember, you can stop the video, work the problem, and then watch the video. So for each of the following examples, you want to determine if repetition is committed and illustrate how that will be managed. So our first example, how many different possible locations could we take if you choose 3 different cities from a list of 20? So, my task, choose 3 cities. City 1, City 2, City 3. Step 2, where am I selecting this from? 20 different cities. So I'm going to draw myself a little box here to represent where these cities are being selected from. Now is step 3, and I actually start counting. When I go for the first city, how many choices do I have? I have 20. Now, here's where I have to decide if something can be repeated or not, or selected more than once. Once I select a city, do I still have 20 cities to choose from, or is it the simple fact that that city cannot be selected again? Well, in the context of this problem, the way it's stated, it says I have to choose 3 different cities. So, if I put the city back, I could pick it again. So I can't because I'm saying 3 different cities. So this number is going to go down to 19 now, right? So when I go for the second city, there are 19 choices. Once again, I can't put that city back in to be selected again, so the 19 is going to drop down to 18. So for my third city, there'll be 18 choices. As explained in another video, we know this is multiplication, and we multiply these together. But there's a 4th step. We're only at the 3rd step. And the 3rd step is here. The intention of this video is identifying a problem to determine if something can be put back or not. The concept of repetition, right? Alright, moving on. As a convention planner, you're given each of 3 organizations the option of where to hold the annual conference from a list of 20 cities. Alright? In this example, we're planning conventions for 3 different organizations, and they have the option to hold their annual conferences in a list of 20 cities. Well, what's missing here is the question, and that question is how many ways you can do it, right? So, as the convention planner, I need to pick a city for the first organization, a city for the second organization, and a city for the third organization. When I select a city, it's going to come from 20 possible cities. That's step 2. Step 3 is I start the selection process. When I select the first city, there are 20 choices. In step 3, we consider repetition, right? That is, when I choose the city that the first organization is going to attend their conference, can I choose that city again for the second and third organization? Doesn't say I can, and I think it's quite obvious that I could, right? New Orleans could be the choice for all 3 organizations. So, I can put the city back. In other words, I'll still have 20 choices when I get to the second organization. I will still have 20 choices when I get to select for the third organization. So even though these two problems are very similar, the difference is one of them I could not choose a city more than once, and in the other one I was able to choose the city multiple times. That is the concept of repetition. Moving on to the next problem. A password consists of 3 letters followed by 2 digits. Suppose the letters can be repeated but not the digits. How many possible passwords are there? Your first step, identify what you need to do. I need to make a password. I need to choose 3 letters. So letter 1, letter 2, letter 3, digit 1, digit 2. That's what I need to do. The letters are going to come from 26 letters. We do not make a distinction between higher and lowercase letters. There are 10 digits out there, 0 to 9. So that's my 2 groups I'm working with. That's where I'm going to be picking from. I start the selection process in step 3, right? So we're at step 3 right now. And that is start selecting. I choose the first letter. Can I put it back? Letters can be repeated. When I choose a letter, I can use it again. So when I choose the next letter, I still have 26 choices. Choose the third letter, I still have 26 choices. Then I get to the digits, but digits cannot be repeated. Digits cannot be repeated, right? So when I choose the first digit, there are 10 digits to pick from. But when I get to the next one, there are only 9. That is the third step. There is a 4th step that will be conducted in a later video. So, remember, repetition, that question is dealt with in the 3rd step of the counting process. Moving on to our last example here. Actually, I have several examples. Another 2 more. In a beauty contest, you need to select from 20 contestants the most attractive, the most talented, and the most interesting. How many ways can you do this? Step 1. I need to choose the most attractive, the most talented, the most interesting. There's no art in terms of the way I represent each of the individual tasks, right? Just using some sort of letter to identify the task. Where are they coming from? 20 contestants. When I start to select, I ask the question if something can be selected more than once. Well, I choose the most attractive, 20 choices. Can the most attractive be the most talented? There's nothing in here that says that can't happen. The most attractive may be the most talented. So when I go for the most talented, there's still 20 contestants. Likewise for the most interesting. The most interesting could be the most talented, could be the most attractive. That is, one person could be selected for all 3. So for all 3, we have 20 choices. That is, we're allowing repetition here. Moving on, again, you can always stop the video and rewind it. For our last problem, we have 12 people applying for both an accounting position and a secretary position. How many ways can we do it? You need to select the accountant. You need to select the secretary. You have 12 choices. They're coming from the same group. We pick the accountant. Step 3, when we start picking, as we pick, we ask if something can be selected again, meaning does it go back in the box? And since we're talking about hiring an accountant position, I would be under the assumption somebody can't hold 2 jobs at the same time. In other words, once the accountant is picked, there's only 11 people remaining in the room to be selected for the secretary position. So that is step 3. Step 4 will involve the concept of order. We have not dealt with the concept of order here. That's why I did not complete these problems here. But we should at least understand the concept of repetition at this particular point in time. Otherwise, watch the video again or contact me. Thank you very much.